Okay, so hello everyone. Today we're introducing our project, the Learning Reusable Abstractions and Agentic Large Language Model Framework for the ARC dataset. So let's first figure out what the tasks we are solving. So we are solving like the ARC dataset, like abstraction and reasoning corpus dataset. It contains two parts. The first part is a small set of input and output pairs. So as you can see, this is a given input, and this is the corresponding output of this task. And it's actually giving like several pairs, roughly like 3 to 5. And we're also giving like a test input, which is only input. And the task is to find the corresponding output for this test input. Okay. So why we're doing this? The main motivation behind the project is because the current large language model often fails for these tasks. So as we can see, this is like a roughly 50% accuracy on the ARC1 dataset, and like for most of the models right now we have, it's around like roughly 50% accuracy. However, like if we're moving to the ARC dataset, like ARC2 dataset, like this is still like the 50% accuracy, but we can see like most of the models right now like it's failing. So like our main motivation behind the project is trying to improve this. Okay, and so what problem are we actually solving on this? Is actually a mismatch between the large language model reality and the abstract reasoning requirements. So for the abstract reasoning requirements, we have like these 4 attributes, which actually requires the model to think like what's the underlying roles behind each task, and once it's understanding roles, it should apply these roles to a new tasks. And sometimes also requires like combine different roles together for just one task. However, for now, right now, the large language model mostly optimized for next token predictions, and it aligns heavily with human instructions, not like just give it like a prompt in the picture, visualized form. So it fails at abstract reasoning. And so why this project is important for us, we think we are trying to moving from like just memorizing patterns to reasoning by building a reusable library of skills. So with all this known, our project goal is to propose a multi-agent large language model architecture that optimizes for the reusability and transferability of learned natural language programs across complex reasoning, the ARC AGI tasks we have. Okay, so for our project, we'll simplify the data to just 1D ARC. So basically, it's just like 1D array here. So each task contains 30 samples, and each sample inside the 31 include 3 pairs for training and 1 input for testing. And it's given in JSON form, as you can see here, and the numbers here representing the colors. So here, it's an example data we have. So this too is the training set. We give it for the model to train to understand the roles we have. And this is the testing input, and this is our model output for this one. So as we can see, it's actually like working to find the correct underlying rules for the given.
So yeah, let's quickly jump to the architecture. The frame is following the intuitions. We split it into the training phase and the testing phase. In the training phase, we build the library to learning from all the previous samples we've seen. And in the testing phase, we use the fully built librarian and the fully built library to actually execute the tasks. So you can see like from the input pairs, we're first passing it to an agent called the orchestrator, which produce a list of meta steps of what sort of actions should be taken in this procedure, which later got passed into a librarian to check in the library in the dataset if we have matching functions. If not, it's going to be passed to developer to create new codes, new functions for reusable functions. And for librarian, it's going to later check in the libraries to see if there are matching functions. Then all the stuff from the orchestrator and the librarian will be passed to the executor to execute the function from end to end to produce the desired output. Once we finish the entire training loop, we're then passed to the testing phase to see if the fully built librarian can actually execute the task. We just input the task input directly and go through the entire pipeline again to get the testing output. So for measure of success, we look for 2 things. One, for the end-to-end accuracy, we're looking for exact match. Does the output of the our agentic system actually match the predicted ground truth outputs? And for the criteria, we just given any ARC-style JSON task, we just output the correct exact print. And we also conduct a component-wise pass rate study to see which of the agent actually falls wrong. And we can see like for each our agents, we have corresponding criteria to match. For example, for the component of producing meta steps, are the steps actually valid? For librarians, are they retrieving the correct functions? So we set up our experiment by choosing 3 subsets of 1D ARC datasets. That's 1D denoising, 1D fill, 1D move 1 pixel. It's quite obvious. With a total of 150 tasks, we passed through GPT-4o Gemini with chain-of-thought prompting styles, GPT 1.5 Flash, and our own framework. And as a quantitative result, we can see our framework is retrieving really high accuracy on training tests, but a little bit less in the testings, as shown in orange, just like other our benchmark models. We can see that from a component-wise analysis, we can see the librarian is actually doing a good job in retrieving the correct functions. Developers writing the correct codes for, this is all done by human evaluations. Executor can conduct end-to-end analysis, produce the function correctly. But for orchestrator to actually do the plannings, it's failing pretty hard. The accuracy is only 30%. We did a qualitative analysis to see which part it actually goes wrong. We can see over here, all the functions over here are actually for moving 1D. So the discussion is, we learned from this that the framework does support LLM to build reusable abstractions as our librarian, and the developers are doing a good job from human eval. And the typing system actually allows LLM to reduce hallucination. The decomposition actually works, but the test time generalization for planner is actually really bad, and we should use some few-shot learning techniques or other learning methods to help the planners to do actually better plannings.